You're watching the second lesson in the grade 7 review for grade 8. In this lesson, we'll be talking about integers and fractions. These two are other aspects of math that tend to get students, so hopefully I can go over these well enough for you to remember them in grade 7, and then if you had trouble with them, help you understand these concepts a bit more. So we're going to start with integers. What's an integer? Well, all it is a number, a whole number that can be positive or negative. What's a whole number? That's easy. A whole number is any number that doesn't have decimals in it. So if it has a decimal in it, not a whole number. That's it. Positive integers are like normal numbers. So if you see a plus sign, or if you just see the number like this, it's a positive integer. You don't have to really worry about it because it's just a regular number. If you know how to use your numbers, it's the same thing. The tricky part comes when you're looking at negative integers. Oops. When you're looking at negative integers. Because they're like their evil twin. They're like the evil twin of normal numbers. So they tend to have some opposite rules. For example, when you look at 8 and 9, well, it's pretty obvious 9 is bigger than 8. But negative 9 is not bigger than negative 8. And that's a very common mistake. If you miss that negative, you're going to say negative 9 is bigger than negative 8. And that's not true. Negative 9 is smaller than negative 8. Right? Negative 8 is bigger than negative 9. Negative 8 is way bigger than negative 587. But on the other side, on the positive end, 587 is much, much bigger than 8. So if I were to draw a number line and put the numbers along this line, you would see 8, 9, 23, 587. But on a number line like this, you would be going this way, and you would see negative 8, negative 9, negative 23, negative 587. And you're moving down and down and down. So the negatives, as the number gets bigger, their value decreases. Now, the most common example used in math with negative integers is money. If you have $23, you have more than someone who has $8. So 23 is bigger than 8, right? Well, if you have negative $23, you owe $23. It means you have less money than the person who owes $8 or has negative $8. And that's it. It's just opposite band. So, when positive numbers, positive integers, meet negative integers, they cancel out. They knock each other out. So let's take a look at negative 8 and 8. Well, you have negative 8, evil 8, and 8. And they collide and they cancel out and you get 0. Well, if you look at 23 and negative 11, well, that negative 11 crashes into that 23 and takes away 11 out of that 23 because it's canceling out the numbers in the 23. So what's left is 12. You have 12 positive numbers left. And again here, we have negative 45 plus 20 equals negative 25. Negative 45, the 20 is canceling out 20 of the negatives. So you end up with negative 25. And again, you have made it bigger. Negative 25 is larger than negative 45. So, what happens when you subtract integers? This is another area where a lot of students make mistakes. A rule I like to talk about is keep change, change. Oops, chog, change. So you have 46 minus negative 5. What do I do? Well, let's do this rule. Keep, change, change. I have 46, right? I have 46. I keep that. I don't touch it. I don't mess with it. Don't look at it. Just leave it alone. Change. Change your symbol. So instead of subtracting, we are now adding. And change. I'm changing this symbol. So instead of negative 5, it's positive 5. Or just 5 if you want. So 46 plus 5 is 51. Right? And that's true for the other question. That's true for this one too. I like to also think of it as you have 46 and you're taking away negative. You're taking away bad. You're making it stronger. It's getting bigger. 51. It's bigger. Let's take a look at this guy. Move this over here. Keep, change, change. Minus 34, so don't touch them. Minus 34, whoops, there we go. Minus 34. And we go change, so positive. Change, and we have 20. That's positive 20, so it's negative 20. So now I have negative 34, and I am adding negative 20. Well, that's making it more negative, right? You're adding more negative, so it's negative 54. So that's the same for this one. You're taking the negative, you're taking away positive, you're making it more negative, you're making it more evil, and you've made it negative 54. Same with this one, negative 68 minus 22, minus 68 plus positive 22. Solve that one on your own. So we can solve questions like this, 3-term questions, just as easily as we solved this one. 32 minus negative 42 plus 10. Well, what do? I have 3 terms instead of 2. Well, ignore the 3rd term. Ignore the 4th. Ignore the 5th. Do these 2 first. 32 minus 42. Keep, change, change. So, whoops, my bad. Where was I? There we go. Keep, change, change. So, keep, change, change. Now, this only works for subtracting integers. Adding integers, you kind of just have to figure out what's happening there. But with subtraction, you can go 32, okay? Keep that 32. I'm ignoring this 10. He's not even there. I'm ignoring him. And change, 42. 32 plus 42 is 64, right? Oh, sorry, not 64, 74. Oh, wow. Right? 4, 5, 6, 7. Yeah. So, 74. Then I just go, oh, plus 10. And I throw in the plus 10. And that becomes 84. Right? So your answer becomes 84. So I deal with 2 of the numbers. I deal with 2 of the numbers on their own. Then I deal with the other term. I add the term later. Deal with it 2 terms at a time. Don't do it all at once because you'll make a mistake. And again, that is what students do. They go, oh, I'm just going to go boop, 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 and knock them all out. Do 10 plus negative 5 first. Then take that number and subtract minus 2. Then add negative 3. Then add 2. And you won't make a mistake. So fractions is the other side of this lesson. It is something else that catches a lot of students. It sometimes catches them off guard and they don't really know what a fraction is. And so hopefully I can help alleviate those concerns. So fractions are supposed to represent parts of a whole. Parts of a whole thing. So if I look at the circle, the whole thing is colored. The whole thing is colored. So it's 1. Easy. So I have this circle. It's cut into 2, but only one of them is shaded. So there's a total of 2 parts here. We see that? Total of 2 parts, and 1 is shaded. We'll take the same circle, cut it into 4 pieces, and only shade in 1 part. Okay, well, 1 part is shaded out of a total of 4. And here we have 3 parts shaded out of a total of 4. So a fraction is telling me how much is shaded or collected or whatever out of the total number of parts. So remember division? We had that square and we divided it by 4 and we cut it into small little pieces like so. Like so. Well, this is that square. This is a smaller square that's divided by 4. That's this larger square divided by 4. Well, that 1 square represents 1/4 of the entire square. So you can use a fraction to represent this square. So let's break it down even further. The division symbol kind of looks like a fraction, right? You have this line, just like that. You have that line, and you have a number here and a number here. You have this line and a blank for a number here and a blank for a number here. Well, let's take a look. Division and fractions are the exact same. 20 divided by 4. Well, let's take the 20 and move them into there, and take the 4 and move them into there, just like this. 20 divided by 4, or 20 over 4, like in this fraction, is 5. Nice. But what about 4 divided by 20? Well, I can take the 4, put it up here, take the 20, and put them down there. And I have 4 over 20. And that's a fraction. Now, there are more steps to be done, but that's a fraction. Division and fractions are the exact same thing. So, when you have 4 over 20, when you have a number like this, you can do more steps. What that means is you can make the fraction smaller, or at least the numbers in the fraction smaller, right? And that's called simplifying. You're making the numbers simpler because the numbers are smaller. So the way you do this is by dividing the top and bottom by a number, not by different numbers, the same number, so that you get a smaller fraction. Well, what number divides into 4, and what number divides into 20? Well, 4 can be divided by 1, 2, and 4. And 20 can be divided by 1, 2, 4, and 5. So, we have numbers that we can use, and all of them divide into either 4 or 20. Well, you pick the highest one they have in common. Well, 4, the highest number that divides into 4 is 4, so we use 4 here. And the highest number that divides into 20 is 5, but it doesn't divide into 4, so we can't use 5. It has to be the same number. If you use a different number, you're not doing anything. So you have to go back and use the 4. They match. They're the highest number they have in common. So you divide both the top and the bottom by 4. Right? You end up with this guy. Now, hopefully you do remember as well, the top part is called the numerator, and the bottom part is called the denominator. So the bottom part, if you go back to the picture, tells you how many parts you have. This has 2 parts, 2. This is 4 parts, 4. This is 4 parts, 4. And the numerator tells you how many parts are shaded or taken or collected. So here we have 1 part out of a total of 2 shaded, so 1 over 2. 1 part out of 4, 1 out of 4. That's a fraction. So in this one, I want you to be able to simplify each of the fractions. What I'm asking is, what number can I divide the top, the numerator, and the bottom, the denominator, by, so that I can get the fraction to be smaller numbers? It's not that I change the fraction. If I go 4 over 20 and 1 over 5, they have the same value. Put 4 over 20, 4 divided by 20 in a calculator. Put 1 divided by 5 in a calculator. You'll get the same number. They're the same value. It's just 4 and 1. Well, 1 is a simpler number. It's smaller. 20 and 5, well, 5 is a simpler number. So it's called simplifying. So let's do the first one here. So if 7 over 14, how can I make that simpler? Well, what divides into 7? 1, and really only 7. What divides into 14? 1, 2, not 3, not 4, not 5, not 6, 7. Well, they both divide by 7, and 7 is the highest number they have in common. So I divide by 7. 7 divided by 7 is 1, and 14 divided by 7 is 2. So 7 over 14 is the same as saying 1 over 2, or 1/2. Again, you can see 1 and 2, small. It's a smaller fraction. It's simpler. It's easier to look at. Try doing that for the others. For example, 3 and 16. What number divides into 3? What number divides into 16? What numbers, I guess. And which one is the highest they have in common? Then solve for that. So, what happens when you run into a situation like this? You have 5 over 4 as a fraction. Well, normal proper fractions, the numerator, the top number, is smaller than your bottom number. Because again, when we look at it, the bottom number denotes how many parts we have, and the top number denotes, well, how many parts are shaded or colored or whatever. Well, you can't shade more than the parts you have. You can't shade 3 parts if you have 2 parts. That doesn't make sense. So we call these types of fraction improper because the top must be smaller than the bottom. It's improper. It is uncouth. So we fix it. How do we do that? Well, remember that fractions are division, right? 5 divided by 4. What it's saying is, how many 4s fit into 5? Well, 1, right? 4 fits into 5 one time. Well, how much do we have left? So I have 5, and I'm dividing it into 4 parts, right? So, sorry. So, how much is left, right? 5 divided by 4. Well, you only have 1 left, right? So if I take this out and I divide it into 4, well, I have 4 parts, and I have 1 left over. So it would be 1, right? I have 1 whole, and I have 1 left over. So 5 divided by 4 will be 1/4. So let's do another example. How do we show this fraction? We have 6/4. So I have 2 whole squares, and I'm trying to show 6/4. Okay, well, 6 are colored. That's what the numerator is telling me. 6 are colored. So I go boop, 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 and boop. Okay, so 6 are now colored. Nice and easy. So how many groups of 4 do we have? Well, we have one group of 4, right? It's divided by 4. So we have one group of 4 here, and how much do we have left? Well, 2. So we can write this as 1, because we have 1 whole here, because that's what it's saying here. We have 1 whole here, right? And then we have 2 left over. We have 1 whole here, we have 2 left over out of 4. Can we simplify further? Well, ignore the 1. 2/4. Can I simplify that? Yes. I can divide this by 2. I can divide this by 2, and our answer will become 1. And I'll have to do that. 1, 1, oops, crooked, but it'll do. 1/2. And that will be our answer, right? Because again, 6/4, well, how many 4s are in this 6? How many 4s are in this 6? Well, we have at least 1 4, so we have 1 whole part, as we can see here. And we have 2 left over. So do these questions, try and simplify the fractions. If you have any trouble, please feel free to ask me in class. Thank you for listening, and see you next lesson.